This is the 2016 Stormwater Pollution Prevention Training. This slideshow will be presented and focusing on post-construction BMP operation and maintenance. BMP stands for Best Management Practices, which are methods of controlling pollutant sources. Post-construction BMPs refer to devices constructed for permanent pollution mitigation due to the impacts of development and redevelopment. They are designed to slow and infiltrate runoff or detain, treat, and filter runoff so only clean water reaches rivers, streams, and the ocean. The Ventura County MS4 permit requires implementation of post-construction BMPs to mitigate adverse environmental impacts associated with development and redevelopment. This includes increased pollutants and runoff volume during rain events, as well as non-stormwater discharges such as over-irrigation and vehicle washing. Urban runoff is the largest source of pollution to Southern California coastal waters. The pictures show examples of runoff with an oily sheen and sediment being transported eventually to the ocean. Changing human behaviors through public education could have a drastic effect on minimizing pollutants. Controlling sediment is important as pollutants attach to it and get washed down into the ocean. And high sediment loads fog water bodies, not allowing sunlight through, which is detrimental to aquatic species. Urban runoff typically includes trash, sediment, oil and grease, metals, nutrients, bacteria, pesticides, and other toxins which negatively impact surface water bodies, recreational use, and aquatic habitat. Any type of pollutant that is on the ground will get washed away into creeks, streams, and the ocean. The pictures here highlight an obvious recreational use issue. Changes in human behavior and large-scale implementation of post-construction BMPs can help keep waterways clean and maintain recreational use of beaches and lakes possible. Trash is a result of littering. Commonly found items are cigarette butts, plastic bottles, and bags. Automobiles are a primary source of metals, oils, and grease in parking lots, roadways, and driveways. A primary source of bacteria is feces from domestic and wild animals. People not picking up after their pets is a large contributor. Toxic organic compounds are found in pesticides used in high-maintenance landscapes and production agriculture. They are also found in industrial, commercial, and industrial cleaners, greasers, and lubricants. The overuse of fertilizers, plant decay, and atmospheric deposition are main sources of nitrogen and phosphorus pollutants. Throughout the following slides, I will discuss several types of post-construction BMPs. I will show pictures and reference specific sites that you may be familiar with as a way of improving your in-field identification of such devices. Most importantly, I'll discuss maintenance activities that will keep the post-construction BMPs functioning per design. Many of you may be involved in performing these activities per maintenance requirements of existing and future facilities. Biannual county-owned BMP inspections are required by the MS4 permit. This includes fire stations, the government center, airports, and other county-owned property with post-construction BMPs. These inspections were recently completed by our water quality inspector, Darren Yant, whom is working with staff at many of the facilities to complete neglected maintenance activities so that these very important water quality devices can operate once again as designed. An important aspect to remember is maintenance frequency. Simple observations during regular site operations can identify items like trash, sediment erosion, oil spills, or clogged inlets that should be remedied at that time. Maintenance frequency of all post-construction BMPs should be conducted before the wet season, after significant storm events, generally greater than 0.25 inches of rain, and again after the wet season. Retention BMPs keep stormwater on site to infiltrate into the ground or reuse it as irrigation or non-potable water within houses and buildings. Examples of retention BMPs will be discussed are infiltration basins, infiltration trenches, bioretention facilities, dry wells, and permeable pavement. Biofiltration BMPs remove pollutants by filtering water through vegetation and soils while allowing the water to drain off-site. The soil and plant-based filtration devices remove pollutants through a variety of physical, biological, and chemical treatment processes. The facilities normally consist of a ponding area, mulch layer, planting soils, plantings, and an underdrain. An infiltration basin consists of an earthen basin constructed in naturally pervious soils with a flat bottom. Energy dissipators are implemented to slow and spread incoming flows, and an emergency overflow structure, which is seen in the picture, is constructed to control bypass flows in excess of the basin's capacity. The bottoms of infiltration basins are typically vegetated with dry land grasses or irrigated turf grass. An infiltration basin is designated to allow the retained runoff to percolate into the underlying native soils within a 72-hour period. If ponded water is present for longer than 72 hours, then mosquito breeding may become an issue. This infiltration basin is located at the Saticoy Public Works Yard. Maintenance for the infiltration basin should include the removal of trash, debris, and deposited sediment. Vegetative health should be assessed. Grass should be mowed to between 4 and 9 inches. Weeds and dead vegetation should be removed, and grass clippings and leaves should be removed as they will impede infiltration. Areas of erosion and scouring should be repaired to prevent further sediment accumulation. If water is noticed in the basin more than 72 hours after the storm, then the infiltration facility may be clogged and maintenance activity may be needed to restore infiltration. Infiltration trenches are long, narrow, gravel-filled trenches that infiltrate stormwater runoff. Infiltration trenches allow runoff to be stored within the void spaces of the gravel and then infiltrate through the sides and bottom of the trench's native soils. They are typically utilized in open areas adjacent to parking lots, driveways, and buildings. The picture on the right was taken before the dirt areas adjacent to the infiltration trench were seeded with grass. The grass pre-treats the water and minimizes the chance of sediment inundation of the trench, which could clog it. Observation wells, as shown in the picture on the left, extend to the bottom of the trench to help verify infiltration and guide maintenance. The maintenance required for infiltration trenches consists of removing trash, debris, and sediment, assessing for poor vegetative health, and removing any weeds that are present. Repairs to areas that show signs of erosion and scouring should also be made to prevent sediment from clogging the gravel. The picture on the right was taken before the surrounding dirt areas were vegetated. If water is noticed in the inlets or observation well of the infiltration trench more than 72 hours after a storm event, the infiltration facility may be clogged. Maintenance activity will be needed to restore infiltration. The picture on the left is one of many infiltration inlets on this site. These inlets have pipes that connect subsurface to the infiltration trench. Keep in mind that not all infiltration trenches are constructed in this manner. This is just an example of the one that is located at the Piru Skate Park. Dry wells are designed to store and infiltrate runoff. A dry well may be either a bored, drilled, or driven shaft or hole whose depth is typically greater than its width. The excavated pit is filled with aggregate surrounding a perforated vertical pipe known as the observation well. Similar to infiltration trenches, they are designed to temporarily store and infiltrate runoff, primarily from rooftops or other impervious areas with low pollutant loading. The diagram on the right illustrates a typical installation where runoff enters a sedimentation manhole where trash, debris, and sediment are trapped and the cleaner water overflows to the dry well for infiltration. This configuration minimizes maintenance requirements and maximizes longevity of the dry well, as the sedimentation manhole acts as a pre-treatment for the dry well to remove potential infiltration clogging pollutants. The picture on the bottom left shows a typical sedimentation manhole, and the picture on the top is the access cover to the dry well's observation well. Some of the fire stations have this configuration on site. Dry well maintenance must be performed frequently to ensure that water infiltrates into the subsurface completely. Sedimentation manholes should be routinely inspected and cleaned out of trash, debris, and accumulated sediments. The infiltration time should not take longer than 72 hours. This can be observed from the observation well inspection pipe following a rain event. If standing water is observed in the observation well beyond 72 hours or 4 days after a rain event, then maintenance is needed to restore infiltration. Permeable pavements contain small voids that allow water to pass through to a stone base reservoir. Some sediments and metals are filtered out while passing through the stone reservoir before percolating into the soil below. For porous pavements to function properly over an expected lifespan of 15 to 20 years, they must be properly sited, designed, and installed, as well as periodically maintained. The top picture is of a precast pervious concrete panel. The bottom is of a permeable paver surface, where water filters through the gaps separating the pavers to infiltrated soils below. Permeable pavement mainly requires simultaneous pressure washing and vacuuming and management of adjacent areas to limit sediment contamination to prevent clogging by fine sediment particles. Routine sweeping with a regenerative air sweeper is recommended to remove sediments and loose debris. The picture in the top right shows oil and greases captured by the pervious concrete from parking lot runoff at the government center. The bottom left shows a Vector truck attachment that is a vacuum and pressure washing occurring simultaneously at the surface. Bioretention and biofiltration are essentially the same, except that biofiltration devices require an underdrain to discharge the cleaned water to a nearby storm drain, whereas bioretention doesn't, since subsurface soils are highly permeable. These types of facilities are landscaped shallow depressions that capture and filter runoff through a soil and plant-based filtration system. They typically consist of a ponding area, usually about 6 inches deep, a mulch layer, ponding depths, and plantings. As water percolates through the planting soil, pollutants are filtered, absorbed, and biodegraded by the soils and plants. In general, maintenance requirements for these BMPs are typically landscape care procedures. The plants should be of a drought-tolerant variety. After the plants have been established, only periodic watering during prolonged dry periods should be needed. Weeding should be infrequent if the appropriate plant species and plant density have been established. Inlet and overflow pipes should be cleared of blockages and underdrains in the case of biofilters. The picture on the top shows trimmed vegetation, an unimpeded inlet pipe, and no trash or debris. The picture on the bottom shows overgrown grass, bent over and matted, as well as leaves that should be removed as both impede filtration and percolation. Accumulated leaves, grass clippings, and fine sediments, as seen in the picture at the top, should be removed, and potential sources of sedimentation deposits should be stabilized, such as the perimeter in the picture on the bottom. Fertilizers and pesticides should be avoided. They may degrade the ability of the devices to process pollutants and will contribute to pollution and overflow situations. If standing water is present 4 days after a rain event, maintenance is needed immediately to restore functionality. Planter boxes are biofiltration treatment control measures that are completely contained within an impermeable structure with an underdrain to avoid water damage to building footings and adjacent structures. As stormwater passes down through the planting soil, pollutants are filtered, absorbed, and biodegraded by the soil and plants. They are typically placed near buildings for treatment of water from downspouts. Repair areas of erosion that may occur due to entering flow velocities. Remove trash and debris and spread out locally accumulated mulch or sediment, as a device functions best when water is distributed evenly throughout the treatment area. Basic landscape vegetation attention is needed to ensure growing vegetation doesn't impede flow spreading or leaves or other debris aren't blocking filtration and percolation. Inlet, overflow, and underdrain piping need to be kept unobstructed. This will avoid flooding scenarios and extend ponding of water, which can lead to mosquito breeding. Vegetated swales are open, shallow channels with low-lying vegetation covering the side slopes and bottom that collect and slowly convey runoff to downstream discharge points. The vegetation lining slows the stormwater flow, allowing pollutants to be filtered and removed through settling and filtration. An effective vegetated swale achieves uniform sheet flow through a flat-bottomed, densely vegetated area for a period of several minutes. Maintenance for vegetative swales include the removal of trash, debris, and deposited sediment. Vegetative health should be assessed. Grass shouldn't be allowed to grow taller than 6 inches high. Weeds and dead vegetation should be removed, and grass clippings and leaves should be removed as they will impede flow. Areas of erosion and scouring should be repaired to prevent further sedimentation accumulation. Inlets to the swale, such as curb cuts or pipes, and end of swale outlets should have blockages removed. If water is noticed in the swale more than 72 hours after a storm, then there is most likely drainage issues resulting from blocked outlets, accumulated sediment, erosion, or vegetation that needs to be addressed to restore functionality. Proprietary biotreatment devices are manufactured treatment BMPs that incorporate plants and soil to mimic natural processes. They are engineered to provide treatment at higher flow rates while utilizing a smaller footprint than their non-proprietary counterparts. Incoming flows are filtered through a planting media before passing on to the underdrain, which delivers the stormwater to the conveyance system. They are typically used in parking lots or in highly urbanized areas where available room is at a minimum. These devices have built-in internal bypasses so that flooding doesn't occur if the units reach capacity during large storms. Manufacturer recommended maintenance activities and frequency should be followed at a minimum to maintain functionality and pollutant reduction effectiveness. Shown here are typical tree box filters. Leaves and other organics often will collect in these units, impeding filtration, resulting in standing water. When this occurs, the organic material rots in the standing water and can cause unpleasant odors. This, of course, will not occur if maintenance is kept up. Often, debris screens will be installed on the inlet to these units to prevent leaves and debris from getting in, helping with long-term maintenance and keeping the debris on the street or parking lot curb, which can be cleaned up by a street sweeper. Here are shown a different variety of treatment BMPs. In the top left is a baffle box, which is usually installed in line with a storm drain pipe. Water enters it, and the heavier materials and pollutants such as sediment and leaves fall down into the sedimentation chambers, while trash and other smaller debris such as leaves or pine needles stay above the water level so that it doesn't go septic and rot. In the top right, you have media filtration, which treats the water through pre-designed media filters. Water usually flows up or through those, and they have to be maintained regularly and replaced typically annually in order to maintain functionality. On the bottom, we have a detention basin. Very simply, it collects the water and allows the water to pond, which forces sediment and other heavier debris to settle down to the bottom, which can be removed from maintenance activities in the future. Treatment BMP maintenance is utilized primarily through Vector truck vacuuming of sedimentation manholes. This removes debris, trash, and sediment that has been captured as the water flows through the device. Blockages for inlets and outlets should be cleared out, and media filters should be replaced per manufacturer recommendations. Catch basin inserts are manufactured filters placed in a drop inlet or catch basin to remove sediment, debris, floating oils, and grease. They are often used as upstream pre-treatment to increase the lifespan of retention and biofiltration BMPs. Trash and large objects can impair the device's ability to capture sediments and hydrocarbons. Frequent maintenance will decrease the likelihood of clogging. The filter liner, gaskets, stainless steel frame, and other components should be serviced at least 3 times a year and replaced as needed. Maintenance of catch basin inserts can be followed in a few steps. First, the access grate or manhole lid needs to be removed. Sediment and debris can then be removed from the top filter portion of the unit. Be careful not to spill the contents and dispose of them properly. Inspect the unit for tears, holes, bending, and missing hangers, and the filter medium and fossil filter pouch should be replaced annually or per recommendation of the manufacturer. Each site that has a county-owned or operated post-construction BMP will be provided a maintenance plan that provides on-site location, type, and required maintenance activities of the BMPs. This slide provides an example of one of those maintenance plans. Fire station number 27 has bioretention and catch basin insert that need to be maintained. The majority of these maintenance plans will be 2 pages. We wanted a very to-the-point reference that doesn't require lengthy, unnecessary reading. Page 1 will generally look like what is shown on the left. It provides the facility name and address as well as what types of BMPs are there, where they are located on site, and what they look like. Page 2 will be the form to be used for inspections and maintenance. It provides room for tracking when and who did the inspection and maintenance, as well as specific things to look for and/or fix as related directly to each type of BMP. You will also notice that from the proprietary items such as catch basin inserts, the model number and link to the manufacturer website will be provided should parts or replacement be necessary. Post-construction BMP operations and maintenance plans for county facilities will be made available in the near future at the web address listed at the top of the slide.